So the talk is about measuring process risk for early insights into software safety, and the emphasis is really going to be on this idea of measuring process risk for emergent properties. And the example we're going to use is some work we've done specifically with NASA on trying to understand the safety risk for systems. So on the outline we have 4 sections. The first one is we're going to first talk about what we mean by emergent properties and process risk, and then we'll talk about the increasing software safety through increasing software safety capabilities through hazard analysis. Then we're going to talk about in detail about the methodology and its application to a specific example, which turns out to be the NASA Constellation program, and then we're going to talk about applying it to Constellation to measure software safety risk. And then we'll talk about some lessons learned and some recommendations in general. So, introduction. In general, non-functional requirements are major cost drivers in the development. I mean, trying to get a system that's not just functionally working, but is reliable and is safe and is secure and it has the right kind of performance are complicated things. And they're important for all systems. And that's usually what ends up costing the money, because it's the problems that we don't get right from the beginning. So non-functional requirements describe desired what we're going to call emergent properties. They don't show up right away. You can't even test them until you're finished with the product, and then you can run them and run your tests and see whether they're working or not. So these are things like safety, reliability, security, performance. The problem with not being able to test them till they're done, if they're not there, then you're in trouble. And it's going to be very difficult to go back and try and build them right back in. In fact, it's conceivable that you can't build them back in because you've made some design decisions in your architecture, for example, early on in the process that really mean you have to redevelop from scratch. In systems development, we ensure the desired emergent properties will be present in our system by applying specific processes. So if you want a system to be safe, for example, you're going to say we're going to do hazard analysis and/or fault tree analysis and/or STAMP. If it's secure, we want to do threat modeling and penetration testing. If it's reliable, we want to talk about probabilistic risk assessment and failure modes and effect analysis. So there are very specific processes that you are applying in the hopes that will improve your chances of developing a system with that particular emergent property, or all of those emergent properties. The challenge, the problem is that the process for achieving those emergent properties are going to work or lower the risk of not achieving that process if the process is capable of achieving the property or mitigating the risk of not achieving the property. So that's the first issue. Just because something is purported to work, it doesn't mean it's going to work. The second issue is that process as is defined appropriate for the context in which you're applying it? Okay, what are all the issues about what is it working, what other techniques are working along with that, and do they integrate well together? And third, second, still on the second, and the staff. Is the staff ready, capable of dealing with that particular process? And the third one is the process is being followed. Very often a process is defined, but it's not actually followed by the people involved. So if a process fails to meet any of these 3 assumptions, there is a risk that the product will not achieve the desired property. So early on, we can take a look at what's going on and say, wow, there's a problem here because either the process isn't working, the process it's not appropriate for the context, or actually people aren't following it. So let's define what we mean by risk, and we'll talk about 2 different kinds of risk. Product risk or technical risk is the risk that a system will not achieve a desired property when it's done. So I look at the product and I say, wow, it's not safe. Okay, so that means what? I have a risk that it's not going to work because it isn't. Then there's a concept called process risk, and the process risk is the risk created by correct or incorrect application of the process that leads to a product risk. So I didn't do the right things. I didn't apply the process. The process wasn't effective enough. It didn't work in the context I'm dealing with. So those are issues that you have to deal with. So a product risk, for example, is an incorrect software implementation of a safety risk. If it takes a rocket if it causes a rocket to prematurely activate its launch booster, that's the product risk. The process risk is that the system may not meet the need, or all software development processes, including process for mitigation risk, introduced additional risks that must also be controlled. So mitigating risks. How do you deal with them? Managing product risks associated with emergent properties is challenging because, as I've said earlier, it's hard to test those properties before the system has been completed. And you really want to try and address them early. So I can track if I can track the fact that I'm not really getting to this place where I want to be able to get to make sure I have one of that emergent property, then I'm going to be in trouble. And mitigating process risk often takes the form of ensuring that the correct process is performed. So in a sense, this is really sort of like a quality assurance process of process conformance evaluations and the application of the process improvement framework. Am I in the right place? How am I doing this? And how can I make fixes before it gets too late? If a process is flawed or not followed, or the context is inappropriate, there's an underlying cause for process nonconformance. So sometimes the developer realizes that this isn't working and so makes changes in real time. And that means, for example, you need to change their process. So the real question here is, how do we ensure that the process is correct, appropriate, and being followed? That's what we're really asking. For any emergent property, when you apply a process, how do you know those things are true? So the idea of, we're into the next section of increasing software safety through hazard analysis, and I'm going to now be specific about software safety. Is an example of an emergent property. So let me define it for a moment for those of you who aren't as familiar, and make sure we're speaking about the same things. A safety risk is a hazard, which is any real or potential condition that can cause injury or illness or death to personnel, damage to or loss of a system, equipment, or property, or damage to the environment. Hazards are caused or contributed to by software have become a greater concern in systems development, as many traditionally hardware-centric systems become highly reliant on software. So there's an interesting issue here, and that's the issue that most systems now have become more software than ever before. And in fact, in many cases, it's predominantly software. First of all, do the people who are doing it believe it? That's the first question. And the second question is, how do they deal with that issue? Because mostly what people have dealt with is when they talk about safety, it's been hardware, certainly within the NASA environment. Software safety is an ideal example of an emergent property that can't be fully tested until the system is operational. So it makes a great example for us. If we look at what a hazard analysis process, yeah, okay. Lucas is going to take the next slide.
Well, good morning, everybody. So Vic's given you a bit of an overview about what the differences are between process risk and product risk and some of the different mitigation strategies. So let's talk a little bit more about a specific example of a process.